Before we look at the available functions in the RE module in Python, let's get a hands-on introduction to the regular expression syntax. One option to test our regular expressions before including them in a program is to use the Pythex website at pythex.org. So here's pythex.org. We have a place to enter our regular expression and then our test string. So what exactly are we testing? So the idea here is that we have a string, our test string, and we are looking for a certain pattern in that string. That pattern that we specify under regular expression may be an email address. We're looking for something at something.com, or maybe a phone number, and so on. So with Pythex, we specify the regular expression, which is just a pattern, and the string we're searching in, and Pythex displays a match result if there is one. Let's start with the simplest case. Let's say that our test string is hello world. Now we want to look for hello in hello world. Hello is the regular expression, and hello world is the text we are examining. So the regex hello matches hello in hello world, so the match is highlighted in green in the match result. So most characters will match themselves. Here, hello matches hello. It's kind of trivial. Now, instead of hello, let's look for lowercase hello. We lose our match. There are no matches. Now let's click on this ignore case tab and we get our match back. So we're telling Pythex here, look for hello and ignore the case. We can change our regular expression to word and we have a match because ignore case is still selected. Some characters are special meta characters. The meta characters don't match themselves. They indicate that some other thing should be matched, or they may affect other parts of the regular expression by repeating that part or changing its meaning. We'll take a look at each one of the meta characters next. We use the square brackets to specify a set of characters that we want to match. We can list the characters individually, as in A, B, C. This means match A or B or C. We can also specify a range of characters as two characters separated by a dash. So A to C, this also means match A, B, or C. If we want to match only lowercase letters, we use A-Z, and so on. Let's change our regular expression to uppercase A to Z. All the letters are matching, but that's because we have ignore case. We disable ignore case, and now we get only the uppercase letters in the match. Let's try a different test string. And a different regular expression. Let's put the ELLO within the square brackets. So the important thing to note here is that everything within the square bracket represents one character, not a sequence of characters. Here we are matching E or L or O. We're not matching ELLO as a sequence of characters. Meta characters are not active inside the square brackets. If we think of meta characters as characters with superpowers, meta characters lose these superpowers when they are inside square brackets. So for example, the $sign is a meta character, but once it goes inside the square bracket, it loses its superpower and becomes just a dollar sign. So if I write square bracket AKM dollar sign, this will match any of the characters AKM or the dollar sign. The caret sign inside the square bracket means not. So here I'm matching H followed by any character that's not a lowercase o. I'm getting HE and H capital O. The dot matches any character except a new line. So here I'm matching T followed by any character. I'm getting T followed by I, T followed by T, T followed by H, T followed by a space character, and so on. Note that the T at the end of this line is not matched. That's because it's followed by a new line character. I can select the dot all flag and then the T followed by the new line character is matched. The caret sign outside the square brackets matches the beginning of the string. So here we're matching any character at the very beginning of our test string. That is B. Now, if we set the multi-line flag on, the caret sign will match the beginning of each line. Similarly, the dollar sign matches the end of the string. So here we are matching any character at the very end of the string. That's T here. If we set the multi-line flag on, we get any character at the end of each line. There are three meta characters that may be used to repeat the character that appears before them in the regular expression. The star means repeat the previous character 0 or more times. The plus sign means repeat the previous character 1 or more times. And the question mark means repeat the previous character 0 or 1 time. So the question mark indicates that the previous character is optional. Let's look at some examples in Pythex. Repetitions are greedy by default. When repeating the O, the matching engine will try to repeat it as many times as possible. So O star PS matches O O O O PS and not OPS or OOPS or OOOPS. It matches as many O's as possible. Let's change our test string. And we still have a match even though there is no O. The star matches the previous character 0 or more times. Suppose we're trying to extract double-quoted string from this test string. I would like to extract this string and this other string. Now, if I write double quote followed by any character 0 or more times, followed by a double quote, I get everything from the first double quote to the last one. This is one match. This is not exactly what I wanted here. Here I want the repetition to be not greedy. I don't want to match as many characters. I want to match 0 or more characters until I encounter the next double quote. So the way I make this repetition non-greedy is I add a question mark to it. And now I have the two strings. Let's try the plus meta character next. So let's try this. And here we don't have a match because we need the O to appear at least once. Plus is for 1 or more. Let's try something else. And here again, the match is greedy. The O was matched 1 or more time, but the matching engine tried to match as many O's as possible. and ended up matching 4 O's. We can make this match not greedy by adding a question mark, just like we did before. And here only 1 O is matched. Let's say we have this string and we would like to capture both spellings of the word color. We can use the question mark to indicate that the U is optional, and we get both spellings. The curly braces are also meta characters. They can also be used to repeat the previous character. We get to specify how many times the previous character is repeated. So here we're trying to capture a phone number. So we are repeating a character between 0 and 9 3 times. That corresponds to the area code. We follow that by a dash, followed by a character between 0 and 9, also repeated exactly 3 times, followed by a dash, followed by a character between 0 and 9, repeated 4 times. And we get the two phone numbers matched. To repeat the O between 2 and 4 times, we specify 2, 4 between the curly braces. And we get B followed by 2 O's, by 3 O's, or 4 O's. We don't get the B followed by a single O here. If we want to repeat a sequence of characters, if I want to repeat the HO, not just the O, we can use parentheses to group the sequence that we want to repeat. So here I want to repeat HO between 2 and 4 times, and I get the ho 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 and ho 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 ho. The vertical bar may be used to indicate an option. So let's say I want to capture both spellings of the word recognize with an S or a Z. I can put S vertical bar Z. That means match either an S or a Z here. The parentheses may be used to group parts of the expression together to indicate precedence, just like we did with recognize or with the curly braces. But the more important role of parentheses is they allow us to capture the matched element into a variable. We call that a capture group, and that capture group may be used later. Let's look at some examples. So here we enclose the area code in parentheses, and then we enclose the following digits into another pair of parentheses. So I'm defining two capture groups here. The first capture group gives me the area code, and the second capture group gives me the rest of the phone number. So if we look in our match capture area, we see that we have two matches, one corresponding to Andrea's phone number and the second one corresponding to Zoe's phone number. But within each match, we have two capture groups. Each capture group corresponds to one pair of parentheses. The backslash may be used as an escape character, and it means treat whatever meta character comes after it as a literal. In other words, the meta characters lose their superpowers when they come after the backslash. For example, in an email address pattern, we want to use the dot to actually denote a dot, not any character. So we precede the dot with a backslash, and that means consider this dot as an actual dot, not as a meta character, and we get the email address matched correctly. Note here that I enclosed the whole regular expression in parentheses because I wanted a capture group. I want the email address to be captured, and I got to see it right here. I have two matches, and each match has one capture group corresponding to the parentheses here. Now, the backslash may also be used to signal a special character. For instance, backslash lowercase t matches any decimal digit. It's the same as 0 to 9. Backslash uppercase t matches any non-digit character. It's the same as not 0 to 9 within the square brackets. Backslash lowercase s matches any white space character. Backslash uppercase s means any non-white space character. Backslash lowercase w means any word character, that is any alphanumeric character or the underscore. So this is the same as A to Z, uppercase A to Z, 0 to 9, and the underscore, all within square brackets. And then backslash uppercase W means any non-word character. So it's the same as not A to Z or uppercase A to Z or 0 to 9 or underscore. And then backslash lowercase b means match word boundary. And this is a very useful special character because word boundary includes not just all the space characters, it also includes punctuation. So it's very useful in identifying words. So these special characters can be used inside the square brackets, and we can put the backslash lowercase s or a comma or a dot inside square brackets, and this will match any white space character or a comma or a dot. Now each of these of course will match a single character. To match two space characters, we need to write backslash s backslash s. Now, when we actually want to match a backslash, we have to escape it, precede it with another backslash. Remember, the backslash is a meta character. We need to take away its superpower to make it behave as a literal. So when we want a single backslash, we have to include two. And here's an example. We have two backslashes in our regular expression, but only one backslash is matched in our match string. And since we're here in Pythex, I want to draw your attention to the Pythex cheat sheet. It's a very useful list. To illustrate the use of special characters, let's suppose that we want to capture email addresses that include digits and special characters, like the ampersand. The pattern that we have used previously does not work here. Using A to Z excludes the 1 to 3 in Andrew 1 to 3, and it also excludes the ampersand in Zoe and Ryan. So we need something different there. We can use the special character backslash capital S to indicate any non-space character, and we get the two email addresses to match, and we also get the capture groups since we had parentheses around the regular expression.